Good morning. I hope I'm audible to the audience who joined online as well. Can someone give a signal? I'll take an introduction of everyone maybe after this lecture so that we'll save some time. We have scheduled one hour break after this lecture. So during that time, I'll take introduction from all of you. So let me move on. So with unknown faces, some of you still I go ahead with the presentation. So myself, Bharat, I've joined this institute in 2012. I'm a professor in the Department of Civil Engineering, also associated in the Center for Disaster Management and Research, Center for Indian Knowledge System, Center for Sustainable Water Research. Apart from that, I'm head of this particular center, Center for Educational Technology. I did my postdoctorate before joining here in University of Saskatchewan. The place is known for unsaturated soil mechanics, kind of Ferdinand worked there, Ferdinand. So that's before that I did my master's PhD both from Indian Institute of Science, Bangalore, where I was introduced to unsaturated soil mechanics in my master's. So after that I worked in University of Saskatchewan in unsaturated soil mechanics. Otherwise, my core competence initially was in soil chemistry. So because geoenvironmental engineering, then I moved to the soil physics, so unsaturated soil mechanics. Right. So I'll take a brief round of the developments and the need for unsaturated soil mechanics for all of us, and maybe more of a pavement related Professor Claudia will discuss about. So generally, currently, the global market, global infrastructure market is projected to be in high numbers, staggered to nearly $8.86 trillion by 2031. So a lot of investment is going on in infrastructure development and globally. In India, if you talk about, there is a PM Ghati Shakti National Master Plan, where they are trying to connect number of ports and also expanding the national highways. So the same thing is also taking place in Northeast India and many other places. So road railway network is developing in faster pace. So the investment by the government of India is also very high. So which is very good because the economic boost also is improving in India, and we have surpassed many countries and we are in third position, right? So fastest growing economy in India. So that is because of the number of projects the government of India has currently engaged in. So mostly road projects and the Sagarmala and other things, if you know, the national highways and other things are getting connected, and the road network is improving even in Northeast India. So this is the PM Gati Shakti brief illustration how different things are getting connected now currently. So as I mentioned, high level of infrastructure investment would also boost our economic growth. Coming to Northeast India, I'm not partial to Northeast India, but I just want to tell that what is going on here in Northeast India. You can also think similar things, what are happening, developments in other parts of the country, right? So because of certain geological conditions or geographical conditions, we face a lot of challenges in the infrastructure development. So therefore, I just want to mention about those things. So also Northeast India, you know that it's landlocked by other countries like China, Bhutan, Burma, Bangladesh, and also if you go to Sikkim, you have Nepal. So other countries are getting associated around the Northeast India. So government is more emphasizing on more developments in Northeast India by engaging or investing in infrastructure growth. So there is a SADF package around 586 crores, and most of that is already released and developments are going on. But however, this is a road and rail network in Northeast India, and generally if you talk about road or railway embankment, we talk about this system. There is subgrade and natural soil at the bottom, as Professor Claudia mentioned in her address, that everything, whatever you do, everything has to rest on soil. So, right? So if soil is good, everything will be taken care. But if soil is not good, whatever the material you put might not be able to withstand the traffic load. Right? As we start our journey in this infrastructure development, a lot of challenges we face, right? Challenges in terms of infrastructure damage, failures, right? So because of the conditions of the soil, conditions of the climatic related things, and also some intervention, human intervention, which is not more of an engineered manner, therefore it caused a lot of damage. So I have to mask some of the photos because these are all taken by us, our research group, during travel across different places. And this is from Manipur, Fiding. I'm sure some of you might be aware of these particular locations, especially those who are from Nanafar, they would know these places. And here the road expansion is taking place, the highway expansion, and this whole thing got collapsed. So right side what you are seeing is sunk into the ground, suddenly disappeared. So the wordings are just, they simply disappeared. And this retaining wall, which is there on the right side, somehow it doesn't work here. If I get a stick, that will be better. Stick, right? So, so this retaining wall tilted, and underneath this retaining wall, even the soil moved to the right side. So there is a Imphal river that flows on the right side, and this is where the damage took place. So here I will not go in detail what exactly caused the failure here, but I just want to give a glimpse of how the infrastructure damages are taking place and try to convince you that how important our unsaturated soil mechanics or the soil behavior is important for these projects. So this is a little up, Manipur, which has Imphal is a valley and surrounded by hills. If you are going slightly up, Jiribam, Imphal region, so this is what is happening. This is a valley side, on the right side there is a valley side, on the left you have a hill. This highway, this is a highway by the way, this is national highway which is connecting Manipur and Assam. So this is getting expanded, but somehow towards the valley side this whole thing got sunk into the ground. So this is the condition of the site just a month ago. I was here a month ago, right? So nearly 1.5 meters the soil sunk into the ground towards the valley side. Sorry. Right? So this is the hill is full of shales. Now the shales are all here as a mud. Shales, of course, weak geological material, and sometimes this becomes a red in color. When it turns to laterite soils, when it got exposed to the air, or because when it is reacting to the oxygen, the iron oxide becomes and it gives a reddish color. Laterites. Sometimes when it is not exposed, then it is black in color only. So this black mud is actually flowing all over. That is because of the the presence of these shales on the left side, and some activity is also going on here. As you can see, the absence of vegetation indicates some activity is going on the hillside, which actually caused a lot of disruption to the springs, natural springs, which are spreading all across and taking away the soil mass towards the valley side. Okay. So this is a condition. The unengineered cutting activity that is taking place all over is causing a lot of damage to the existing infrastructure. This is very close to IIT campus called Karguli, hardly 1 hour. Right, so here also there was a slide that took place. This is slightly simulating the mud flow conditions, not exactly landslide, mud flow conditions that have taken place in 2022, but again it continued year after year, right? So sometimes even the damage could be, because of rock fall. This is hardly a kilometer away from the place where we are, just outside IIT. This was in 2022. Exactly same time, Karguli Hill, where I showed you, and this particular failure, and there's another failure that took place within 3 days interval. There was a peak COVID time, 2022, June. Okay, so that's what we faced during that time, 2021, I believe, 2021 June, right? So these three, I was telling that Joyguru and this one Karguli, all these things took place 20 June. Right, so during that time, even in Shillong bypass, if you observe the dates, dates are months. June, September, these are very important. I'll just get back to you. What is the significance of these months of the failure that have taken place? So this is Shillong bypass, and they were trying to make benches and trying to protect using bamboo. And this is Nehu, 2019, near sports complex. The breast wall also collapsed here, if you see. So this is kind of a laterite soil, right? And these two on the left hand side are West Kameng, Rupa in Arunachal Pradesh, where some hydroelectric project work is going on, and consecutively 2 years there was a collapse, the tunnel got damaged, and they could not get the proper yield of the electric supply. Actually, this particular hydroelectric project supplies to even government of Arunachal Pradesh. So this got interrupted, and this particular is Likabali site, Alo in Arunachal Pradesh, where this whole hill started moving. On the right hand side, the hill started moving towards the left, and there's a river that is flowing, and where it takes a turn, deroots, that's where actually this whole thing actually is happening. Even though there is a bridge that is connecting, which got uplifted. The bridge abutment got uplifted over here. This is an important road which connects Arunachal Pradesh with Assam, near Dhimaji district, right? So this is what has happened. And coming to rail networks, this is a awful condition that happened in Aflong in 2022. So far, whatever the scenarios I've showed you, mostly what have happened in the month of June, but this happened in May. Okay, I haven't discussed about the rainfall, etc. I'll come to that very soon. So this happened in the May. Aflong is one of the districts of Assam, very close from here. Hardly 3 years by road it takes. Right, so a devastating thing, mud flow that has taken place. So this is the train, whatever you are seeing rail, that is in a valley which is surrounded by 2 hills on the left and right. So entire flow has taken place from left and right, both sides. Left is more contributed, and continuous incessant rains caused a lot of flow of the soil mass from the surface to come down and accumulate here, and completely got submerged the train and also tilted the trains. So this is what has happened. And also there are a number of cases where heaving and collapse also takes place. So this is in Tripura, Agartala railway site, in fact. So right where Bangladesh and India had a railway line. So Ircon project actually. So where there was a PTB building, passenger terminal building was actually planned, where they planned number of piles for the PTB, very light structure, but then planned with piles. These piles sunk into the ground, some of them upheaved by 1 meter. First time I heard piles getting upheaved by 1 meter. So this is how got what I could analyze aftermath is that there was on the right hand side up, if you see, there is a water body you are seeing, where there is a railway track, where they are actually doing PVDs. prefabricated vertical drains to stabilize the soil after the development of the PTB. Okay, so PTB itself is located on a very soft ground. So because it is very soft, they actually design piles. Right, so some of the piles sunk, but later on again they got few more piles. Now everything is designed next to the PTB building, the site they were developing during that time. So whole soil mass was sinking because of accelerated consolidation. This soil mass started pushing the soil to left side, so some of the piles got upheaved. So this is the problem that has happened, and so you have pretty much soft soil somewhere like in Tripura, and also some of the shales, sandstones, clay stones in many parts of Assam, Meghalaya, Arunachal Pradesh, and these different type of variety of geology is present all across. So which can replicate the entire India, I believe. Right, so there is another case which is quite interesting to me and bit quite challenging. So this is in Manipur, Tupul. This is a very tragedy, 71 people died when this particular landslide took place. Again in 2022, I believe, on June 30th, when the yard is getting developed, railway yard is getting developed. There is a tunnel. So I don't know, yeah, you can see the tunnel portal. So from there the rail is supposed to come and stop over here, and then again it enters to another tunnel. So this is just a yard, railway station. Right, so for making this railway yard, they were making benches, and you can see that this is the geology. You can see the dip very clearly, and this is again a combination of sandstone and shales. So that's the layer that is actually present. And when they were making the benches, one fine day, everything gave up. The important thing is, if you see the numbers, this is Isai river that is flowing on the downstream, and on the up, if you see top of the mountain, which is nearly 1 kilometers up from the Isai river. That is a huge, from Isai river, the top of the mountain is nearly 1000 meters elevation, right? So doing a total station survey, anything is very difficult, right? So that is the challenge, and typically rainfall induced landslides are shallow in nature, hardly 2 meters or so, right? But here the slip lane itself is 60 meter deep because of continuous rains for sure. But there are a lot of lineaments that were present, and also this is zone 5, seismic zone 5, right? So because of this earthquakes that took place nearly 8-9 years previously, that caused a lot of development of the lineaments and a lot of fault zones through which I think it's slided. So this is a failure in Manipur, and similarly the railway network, if we talk about, similar problems were faced. I'm sure our NFR colleagues, engineers are currently working or maybe in the same place. This is Lumding to Badrapur section. Okay. So both sides you have a hill, and this is the condition of the soil there. Poor drainage network, which actually chokes the existing retaining walls. Most of these weep holes are ineffective because they would not have covered or used any geotextile or anything that would have got exposed directly to the backfill, natural soil itself. They would have choked. That is a condition. So which actually causes a lot of pore pressure to develop, very high pore pressures. We can't even imagine how much pore pressures really get developed. So it can push the Gabion wall, huge Gabion walls. It can push. Generally, we think that Gabion walls are, very useful because they have a lot of porous material in between porous structure, and it can allow free water to drain. But then it can get choked, and same pore water pressure, soil pressure can push the Gabion walls. So these are all sites, this is the Gabion wall, which is got buried under the soil. This Niger fighting. So in the existing drain network got disrupted. So this is the gabion wall which got pushed by the soil mass. So look at here on the left and right, the bulged gabion wall which is coming very close to the rail train, right? So that's the soil pressure that it can exert. Similarly, we have stream bank erosions because we are all on the banks of Brahmaputra, which is a very long network, and so we have continuous erosion of these banks that is also taking place. So what could be the reason of the failures? We can always blame climate, right? Partially that is true, but our understanding of soil behavior is also important. If that understanding is not there, the failure is inevitable, right? So currently, because of the climatic conditions, what they say that the temperatures are slightly increasing up. Because of that, the evaporations are increasing, and the randomness or variability in the rainfall is also increasing. So we call something called a return period. So there is a particular rainfall intensity which returns after certain duration. This is getting disrupted. So for example, there is a particular rainfall that has happened in 2022 in Offlong area, which caused a mud flow. Similar rainfall intensity may not happen every year. It may return after 50 years or 60 years, but that gets changed because of the climatic conditions. It may happen that within 20 years it will return, right? So our infrastructure should be ready or should be good enough to take care of these return periods. So that is called a disaster resilient infrastructure, right? So which is adapting to the climatic conditions, changing climatic conditions. Second one is the infrastructure what we are putting. It should be sustainable. It should be economical at the same time, environmental friendly. So that is another aspect that what they're talking about. Sometimes geosynthetics are thought to be of sustainable because they can keep the infrastructure intact for a longer period of time. You don't need to reinvest on the infrastructure repeatedly, therefore that is considered to be sustainable. From others thought, because again you are using the plastic material, right? Polystyrene, polyester, and high density polyethylene materials, etc. you are using. So considering geonaturals is more sustainable. So both things are there, but if you are investing on geonaturals, again they have to be revisited. But there are other ways to coat them and then place it for a longer period. That's another way we are trying to address. So so the variability in rainfall, etc., that climatic resilient thing is actually coming in there. So also concentrated larger intensity rainfall is taking place at one place, which can also cause a lot of damage. So coming to the climatic changes, before that let us understand the geography or geology of this particular region itself. The location of this particular thing, Northeast India, which has a lot of mountains all around. Even the campus is surrounded by several mountains, right? Although we are in valley, this is a valley, Assam Valley, and a number of mountains are surrounded, but it has a weak geology and high rainfall. So the highest rainfall place is hardly any distance from here, and high seismic zone. So these are all contributing to rainfall. The damages that we are discussing about. And one particular scenario which I asked Vishnu to prepare yesterday. So the rainfall patterns in Northeast India. So pattern, if you see, they are increasing every year. So another aspect, if you see the rainfall that has happened in the Offlong in the second picture during that 2020. So if you see the May generally April, May, it's a very pleasant time here because we have a pre-monsoon. Actual monsoon supposed to start from June onwards, which is called southwest monsoon. The southwest winds come here, and southwest monsoon starts nearly on the third week of June. June 21st, 22nd, sometime that it starts. It originates from Kerala. Kerala, it starts around the first week of June, then Western Ghats and comes here, which starts around third week of June. So most of the landslides, what you see, have occurred during the June, July, August, September. Until then, you have rainfall. Then it retreats, and it starts. Rainfall starts in the southern part, which is called northeast rainfall. Northeastern winds moves towards that. Like Chennai, it rains in November, December. Right? So that is a general pattern here. Now, before June itself, you have called something called pre-monsoon. So from October to February to March, it's a dry period. Soil moisture condition is like a very dry. Even the relative humidity is nearly 40%. Very dry, right? And there is no rainfall. So what happens? The soil moisture is very, very low. So that is a condition. And the pre-monsoon starts in the month of April or so. April, May, you expect a lot of floods happening here in the valley. Because soil moisture is low, most of the runoff takes place. Water infiltration is less compared to runoff. Most of the runoff takes place towards the valley side from the hills, and flooding takes place. Similar flooding caused a mud flow to take place in Haflong district. Okay, that happened before June. That is not a real landslide. So landslide would start in the month of June once soil moisture slightly sets in. Some moisture is there, so that you will get to see, the hydraulic conductivity improves. So therefore, moisture gets into, or infiltration takes place. Soil gets more and more wet, more and more moisture gets into the soil. So infiltration is increasing. So which can cause some landslide to take place, rainfall-induced landslides. So these phenomena, if you understand, it will be very clear. So when soil moisture is low, floods take place, and when moisture is very high, it can cause landslides. So this variability, sometimes, pre-monsoon starts a little early, sometimes a little late, which can disrupt these things. And sometimes the intensity increases. These are all causing a lot of damage, So therefore, understanding of these things is very important. So in the northeastern part, mostly shales you will see everywhere, right? Maybe once you go to Arunachal Pradesh, you will get to see graphite, schist, and other things, and other places mostly shales. Gneisses also you have, and these things are very common in different places, right? In northeast India, mica schist is also present in Rupa and other places. So I was just mentioning, in a climate resilient infrastructure, what we are talking about. You may have a retaining wall, something called a crib wall, which is actually placed there, and you may have, nails or anchors, SD anchors or something like that, and also sometimes along with some bioengineering, where we are currently working on how to arrest the mud flow scenarios, etc. Certain bioengineering techniques, certain grass varieties to prevent mud flow or even shallow landslide to take place, right? So these are other climate resilient infrastructure development what we are thinking of. So what we should discuss about. So some applications of GIS and remote sensing I'll try to discuss, because first of all we need to assess the damage and assess the conditions of the site to even recommend certain solutions, right? So for example, as I mentioned in Tupul landslide in Manipur, which is a large area, nearly 1 kilometer from Isa river to the top of the mountain. So TS, total station survey, is nearly impossible to do that, right? So then some of these GIS or satellite based methods are handy to understand what is going on there, right? So So some of my students are working, so they use either optical data or thermal remote or digital elevation, microwave remote sensing models. And optical remote sensing data is good, but in Northeast India we have the cloud coverage problem where you will not get the good images. So we rely on microwave data for such cases, right? So they work with different frequencies, and these are some of the sources where we get the data from. And these are freely available sources, data where you can download the satellite images and then we can see what is going on. We need to process, a lot of processing of course is involved. So and SAR is also used, synthetic aperture radar, and I'll skip these things. I'll directly go to how the analysis actually is made. In this lecture I just want you to tell different options what we have available and how they could be used, integrated together to solve a problem. So this is for the same tuple site. If you see the data nearly for 2 years before the landslide also, there is a movement that is taking place. So because it can capture even a millimeter changes that happen to the site, so it is possible to recognize what changes that are happening in the site. Large site, there is a continuous movement that is taking place. For example, if you are doing a shearing test, direct shear box test, you will use certain shear rate, strain rate, but you will be continuously shearing, it will start failing at some place, right? So same thing happens in the field. Large mountain, it is kind of part of the hill is kind of moving slowly, and it gave up some other time. The strain is developing within the soil, and that could be detected only by remotely if it is a large place. Otherwise, it is not possible, right? Similarly, this is close to Dhanesh place. This is a Futsero, Fak district in Nagaland. So there is a lot of damage on the valley side. This is the hillside on the left down, and the right is a valley side. And there is a electric station that is going to be built. Partly it is built, but after that there is a failure that has happened. So look at I forgot to mask the faces. Please apologize. There's a shear plane. This is where the shear plane got developed and it is actually moving down. So if you see the pole, which nearly got shifted by 1.5 meters from left to right. On the left side picture, there are 2 yellow arrows, right? So this pole got shifted and going down. So continuous failure that is happening at this particular place. So I visited the site nearly 1.5 years ago along with Dhanesh, and currently it's in a different shape altogether because 3-4 landslide took place between this duration. So look at the gabion wall's condition. Gabion wall even got pushed. So that's the amount of pressure that gets generated. Soil exerts a huge pressure, right? So this is a bus station for the electric thing, and these are the retaining wall failure. And here, this kind of picture would really help. So for that, you need to have a total station survey and levels contour map you generate either using the lidar or total station survey, or sometimes through DEM, digital elevation models. But DEM would be difficult unless until you get a recent one. So then once you have this profile, you can actually place that which bench has what, right? So you can place all those things and then understand what is actually happening. Then after that, next thing is borehole data or some geophysical data. Geophysical data also should have some ground truth like boreholes. Then you combine these two things and then try to map on the same thing so that you will understand how the layering is changing. So then try to understand where it is actually failing. You require something else also, that is drainage map. Drainage map of this particular location helps in how the movement of the flow takes place. So that is where essentially is taking the soil away from. So for this we developed the DEM, digital elevation model. Through that the flow channels have been understood, the drainage map has been developed, and most of the flow is taking place through our site, that particular site. If they had chosen some other site beyond this, it would have been safer. So these planning should come beforehand. If you are planning for important site, that should come before, right? So that's how the some of these satellite or remote sensing models would really help. And briefly, I'll touch upon what is the mechanism for the general failures. So definitely one cause is the water. Water has to be channelized, right? So you may have a lot of springs or rainfall water which is actually coming down, that has to be channelized and it should go to the valley. And if you don't pay attention, it will take the soil also along with it, right? Very quickly, I try to want to mention. So we always say that the angle of repose, when you take a dry soil mass and then try to dump, it takes a shape, right? Heap. That heap angle, if you measure, that is angle of repose, which will be angle of internal flexion as well. If you take a dry sandy soil mass, if you don't believe in cohesion, then even for clay soils, this is the same. So there are different schools of thought, British school of thought and American school of thought. So British school of thought doesn't believe in cohesion at all. So anyway, so whether you believe in or not, if you take a sandy soil, definitely there is a friction angle, angle of internal friction, which is equal to the angle of repose. So that means any given soil, dry soil mass, can be stable with this angle of repose. How much this angle of repose can be? Our angle of internal friction of a soil could be less than 40 degrees. So any slope can be stable with 40 degrees. But you may see that even sand, this Ganesha thing that was made, part of it is even 90 degrees vertical. How this is possible? This is possible because of surface tension. Partly saturated soil, unsaturated soil mass. When the soil is partly saturated, there is a development of surface tension. There are capillary forces, there are adsorption forces for some soils. There's a matrix or the osmotic potential which actually translates to negative pore water pressure under unsaturated conditions. These conditions make the soil even stable more than its angle of repose. So most of the soils or slopes are intact because of this reason, also because of presence of some vegetation. As the roots etc., they impart some cohesion and also give some reinforcement. Because of that, they are stable. But when the rainfall comes, it wets, right? As the saturation takes place, the shear strength drops back to the same, what you see in the dry condition are completely wet conditions. So it fails. So essentially that is what is actually making it to fail. So when you have a slope, you create a road. Some I'm not able to show, but then there's a road, right? Generally you will have a breast wall here, retaining wall there, and then maybe whatever the backfill you use, and you go on, right? But until you see that the water, subsurface and surface water, which is properly drained out, are channeled towards the valley, which can take your retaining walls also along with it towards the valley. So this is what can happen, So we understand that there are different shear strengths. Shear strength can vary with moisture, right? So how the shear strength can vary with moisture, how the soil moisture can change its hydraulic characteristics, all those things are very, very important, fundamental to understanding of these, addressing these things, right? So essentially there are different mechanisms, of course. What I showed you is only one mechanism. There are rockfall. So rockfall also takes place, very common in Nagaland, right? Sikkim. Nagaland, last year it happened and this year also it happened. Between, Dimapur and Kohima, that road. So people died, suddenly, with no time, there's no breathing time, suddenly it drops on your head, right? From nowhere. And after that, they had a rock bolting and passive nets. But still, this happened this year. So you have to calculate the energy, and based on that, the redesigning is required, right? So similarly, mud flow, very common in Sikkim. This year also it happened 2 months ago. So mud flow is very, very common, and landslides are very common in all different parts of the northeast and north, and similarly in south in Kerala, and also in the Western Ghats say Maharashtra and other places. So we are all are getting affected, right? So this particular problem is not an isolated problem in India, right? Similarly outside also. Japan faces the same problem and many other countries face the same problem. So mud flow, there are number of solutions like Sabo dam, etc. For that again, understanding how the flow takes place, initiates, is important. So I'll take maybe a few questions, or I'll take an introduction, then we'll have a break. During that also we can talk, right? So can I have a quick round of introduction from each one of you? So maybe we'll start with online. Who is going to speak first? Just say, call out name otherwise. Call out name.
Imad this time.
Hi Imad. Can you please introduce?
Hi, this is Imaduddin from. Yes, I am a PhD scholar in IIT Hyderabad. So I am doing PhD in the climate resilient infrastructure pertaining to railway subgrade. I'm belongs to Bihar, Muzaffarpur, and I completed my bachelor's from Maulana Azad College of Engineering Technology, Patna. Then I moved to BIT Mesa for my master's from 18 to 2022. After that, I joined IIT Dhanbad under the Dr. Rajiv Sarkar for the GRF project. It was on the glass-induced ground vibration on the mine slope. After that, I joined here as a PhD scholar back in 2023. So I have completed my coursework and all.
Who is your supervisor, Imad?
Dr. Roshan Khan.
Okay. Thank you.
Thank you.
Yeah.
Bhavitra, are you saying something? It's not audible.
You call somebody else.
Ayush Raj, are you there? Can you please introduce yourself? Ayush, are you there? Nikhil Ranka, can you please introduce yourself?
Hi everybody, happy to be here. I'm Nikhil Ranka. I'm with Zydex Industries, and my background is in chemical engineering and polymer chemistry, and we are interested in this course for basically a lot of the unsaturated soil mechanics, where we have certain technologies that can fundamentally reduce the suction effects in soils, and we would like to explore their application in pavement subgrades and granular materials. Thank you.
Thank you, Nikhil. Partha, can you please introduce yourself?
Hello everyone, hope I'm audible and visible as well.
No, not visible.
I'm not visible. Okay, actually I'm using my mobile. First of all, my sincere apologies because I'm traveling to one place today, but nonetheless, I didn't want to miss Professor Bharat's lecture, so I have joined in my mobile. Yeah, so good morning everyone. This is Partha Das. Yeah, it's a nostalgia for me because I have done my PhD under Professor Bharat, and I completed it in 2021. A lot of familiar faces, so indeed a wonderful, so to say, exposure for me. And I was actually looking forward to this Gyan course too, and wanted to desperately have it, attend it offline, but somehow due to some personal and no professional reasons, I couldn't. So this course is something which is very relevant to all this ongoing, climate, climate related failures, and myself have recently ventured into this rainfall induced landslide. Of course, thanks to Bharat sir, because he has guided me during my PhD. Part of my work was also related to understanding the mechanism behind this rainfall induced landslide, particularly shallow landslides. So some of it has also been discussed just now by sir. So yeah, this would be very helpful for me, and looking forward to all the lectures. And yes, thanks to IIT Guwahati for giving me this opportunity, and also looking forward to attend the talk of Professor Claudia. So I believe, it will be a great exposure for me. Thank you. Thanks, everyone.
Thank you, Partha. Rohit Sharma, are you there? Can you please introduce yourself?
Hello, I hope I am audible.
Yes. Rohit, you are audible. Uh, Rohit, it's not audible now.
Call somebody else. Ayush, Satya, Aditya. Others will take
Ro-
from here.
Rohit, you are not audible. Please try.
Yeah, hello. Yeah, am I audible now?
Yes, yes.
Yeah, sorry, actually my laptop just got hanged, so I have connected again through my mobile. So yeah, hello everyone. So this is Rohit Sharma. I have completed my PhD recently at IIT Bombay under Professor Dharamveer Singh, and currently now I am in Zydex Industries. So we have been working a lot on soil stabilization, and we want to further explore this on the saturation and unsaturation behavior also. So yeah, so looking forward to this like very interesting topic, climate resistant transportation geotechniques. So here to learn more about this from Professor Bharat and Professor Claudia. Yeah, thank you.
Thank you, Rohit. TVS Aditya, are you here? Can you please introduce yourself?
Am I audible?
Yes, you are audible. Please continue.
Yeah, I have to apologize first because I am traveling by train right now. So my voice might not be that clear. But
Aditya, you are inaudible.
hello?
Yes,
Hello.
please continue.
Uh, sorry for this. So I'm current.
It's okay, Aditya. Yes, we'll connect back. Aditya, please mute yourself.
IIT Guwahati itself. I'm from geotechnical department. I'm currently working on the effect of soil instability in the pavement structure lifetime. So, thank you.
Hello everyone, I am Milay Raja, Assistant Professor in the Department of Civil Engineering from PSG Institute of Technology and Applied Research, Coimbatore, Tamil Nadu. And I am working on my PhD, the rainfall-induced landslides in Western Ghats and its mechanism. So I am here to learn about unsaturated soil mechanics and hydraulic conductivity of soil. So thank you.
Good morning, everyone. My name is Amit Singh, and I did my master's and MTech from IIT BHU on the topic of consolidation of saturated and unsaturated soil. And currently, I am working with Dr. Bharat sir in drying induced consolidation.
Good morning, everyone. I am Pushkarna Chaurasia. I am come from IIT BHU Varanasi. I am doing my PhD under Manas Chakrabarti sir, and I am working on different problem like seepage for slope stability, and I am also working on the viscoelastic material consolidation problem and some changing the boundary conditions. Thank you.
Hello everyone and a very good morning. Myself Dr. Dhanesh Singh Das. Currently I'm working as an assistant professor at NIT Nagaland, and also I'm one of his previous PhD student. With him almost I worked for around 9 years, and mostly we focused on whatever sir has discussed. Mostly we focus on understanding fundamental understanding about not only unsaturated soil, apart from that different kind of expansive soil and clay soil. Thank you.
Hello everyone. Myself Dr. Himanshu Yadav. Currently I am working as a postdoc fellow in IIT Bombay. So previously I was just here only as a PhD with Professor Bharat only. So I was mostly working on contaminant transport related problem. So now there at IIT Bombay I recently started on pavement geotechnics. So that's all.
Hello everyone, myself Damadara Palaval sir. I did my masters under Bharat sir only. I worked on the area of lateral earth pressure evolution under transient flow conditions caused by the various rainfall events. Currently I am working for a company called Vedantas.
Good morning everyone. I am senior section engineer. I am Rajkumar Mistry, senior section engineer works from NF Railway Silchar. And I am here to mainly, we are the main sufferer of slope failure and breast wall failure and everything. So most easy and most practical technologies we want to learn so that we can implement in field. Thank you, sir.
Good morning, everyone. I am Sanjay Sutradhar, coming from Agartala. I am working in the NF Railway learning division under. I am learning. Today I am here for learning for GAIN course under climate regulation and transportation geotechnics. Thank you, sir.
Good morning to everyone. I am Utpal Kumar, presently working as senior section engineer, works under NF Railway. So I want to learn the physical failure of slope failure and river meandering protection work. So I could come here to learn from Sir Bharat sir.
Hello everyone, I am Pradeep Kumar. I am also from NF Railway, working as a senior section engineer. Thank you.
Hello everyone, I am Adarsh Kumar from DRA Infracon Private Limited. So I have done my bachelor's from NIT Silchar in Assam only, and then I have done master's from IIT Gandhinagar under Professor Amit Prashant. So basically most of these slides and picture which sir have shown, some or the other way they are our projects. So DRA Infracon is executing and designing the project of the Narim Banglo Badarpur section in Haflong. Guwahati Ring Road project which is coming is our project only as of now. We are doing projects in Silchar, Agartala bypass. The sir shown the picture of that terminal building. So just beside that we are having the Agartala Western bypass, which is connecting that Nischintpur railway station, for which picture was there. So we are executing that. So one or the other way, we want to increase our GAN to execute such projects and design, and these GAN goals will be certainly helpful as it is pinpointed on that target only. So special thank to Bharat sir and Professor Claudia. So we will have a good time and hopefully we'll implement these things in our projects. Thank you.
Good morning everyone. My name is Payal Dandil and I am colleague of the Mr. Adarsh Kumar. I have completed my Master of Engineering in Geotechnical itself from the LD College of Engineering, Ahmedabad.
Good morning everyone. Myself Annapurna Badalmat. I am a PhD scholar at IIT Dharwad. I am working with Professor Giridhar Rajesh Bande. And my research area is related to climate resilient of transportation geotechnics, that or basically the railway substructures. And I'm here to learn more things about unsaturated soil mechanics basically. And I thank Bharat sir for giving me this opportunity. Thank you, sir.
Hi all, I am Abhishek Power and I am from IIT Dharwad, PhD scholar under Girdhar Rajesh sir Bande, and basically my research area is rainfall induced landslides, so I came here to learn basics of the unsaturated soil mechanics, and I thank for this opportunity, sir.
Good morning, everyone. Myself Vishnu. I'm a PhD scholar. I work on bioengineered and sustainable solution for rainfall-induced landslide through experimental and theoretical modeling. I work under Professor Bharat, and I'm looking forward for this GAN course. Actually, I've been working on mostly on slopes, so the pavement aspects will give new insights into my further research journey. Thank you.
Good morning, everyone. I am Sahil Kumar and I am working with Professor T.V. Bharat. I am a PhD fourth year student in the Department of Civil Engineering and currently working in the area of role of microorganisms in the chemomechanical behavior of clays. In this GAN course, I just want to explore the unsaturated soil mechanics from the renowned experts like Professor T.V. Bharat and Professor Claudiana. Thank you.
Hello everyone, myself Abhishek Pal. I am working in NF Railway as a senior section engineer works. Thank you.
Good morning, everyone. I am Jitendra Kumar. I am currently working in NF Railway, belonging to half-long section, which is many problems like slow failure, retaining wall failure. So I am here to learn unsaturated behavior of soils. Thank you.
Good morning, everyone. I'm Rahul Reddy. I did my PhD from IIT Kharagpur under Professor Reddy. My research area was on cement asphalt composites for high-speed rail slab track systems as vibrational dampers. I'm currently working with Zydex Industries, a specialty chemical company working on surface modifications and additives for asphalt and granular materials. After joining the company, I started reading fundamentally from again soil because my background is into asphalt. I have to start again. So this course was at the right time for me. Yeah.
Hello all. I'm Basil. I'm Basil Jaimon. I'm a faculty of civil engineering, one of the government college in Kerala, and I also am research scholar here in IIT Guwahati under Professor Srideep Shekaran. And I work on surface modification techniques and pavements under wet conditions.
Namaste everyone. I am Abhishek Shandilya, pursuing my PhD working under the guidance of Sir. And my area of PhD is like some aspects of building construction by ancient Indian method, because I'm associated with Center for Indian Knowledge System and I'm working in that direction only. Thank you.
Good morning, everyone. Myself, Mahesh. I am working under Professor T.V. Bharat. My research area is application of geonaturals toward resilient disaster infrastructure. Thank you.
Hello everyone, my name is Achinta and I'm second year MTech student under the guidance of TV Bharat sir, and currently I am working on bioengineered slope stability.
Hello, my name is Bhargav Fukan. I am a research scholar from Civil Engineering Department. Currently, I am working on solute transport in unsaturated zone. So for me, learning about unsaturated zone and the fluid is very helpful. Thank you.
Good morning, everyone. My name is Minma Adhikari. I am a third year BTech student from Dispur University. I did my internship under Professor Bharat sir on rainfall prediction. So here I really look forward to learn about unsaturated soil mechanics. And I really thank Bharat sir for this opportunity. Thank you.
Good morning, everyone. Myself, Trishant Dargdar, a third year BTech student from Tejpur University. Previously, I did my internship under Professor Santugar sir under BI model development and cost estimation and that labor and all.
Good morning, everyone. Myself, Abdul Alfarooq Ahmed. I am from Tezpur University. And I am a third year BTech student in Department of Civil Engineering. Thank you.
Good morning, everyone. I'm Polomi Pradhan, a PhD scholar currently working under TV Bharat sir, and my research area is phytoremediation. It's geo-environment area. Thank you.
Good morning, everyone. Myself, Pulavita Sharma. I am a MTech student from Tejpur University. Currently, I am doing my MTech project under Professor Bharat on understanding rainfall-induced landslides. Thank you.
Professor Srinivas, can you please introduce yourself? Professor Srinivas, are you there? Bhavitra, are you saying something? It's not audible.
Is it audible now?
Yes, please continue.
Good morning, everyone. I am Bhavitra. I'm a research scholar from NIT Puducherry. My research area is landslides and slope stability. Currently, I'm a fourth year PhD scholar working in the unsaturated shears and characteristics of lateritic soil in Nilgiris and its influence in landslides. I thank Professor Bharat and Professor Claudia for this wonderful opportunity in unsaturated soil mechanics. Thank you.
Thank you. So we'll come back in 15 minutes.